This is one of the largest, most sophisticated, complex machines ever built by humans. In the thousands of hours that this is going to spend in the air, if anything were to go wrong, even once, then the results could be catastrophic. So in this place, their job is to make sure that never happens. In the 8 years since the first of these massive planes came into service, 100 million people have flown on them. Remarkably, in all that time, not a single life has been lost in one due to malfunction. It is an extraordinary achievement. These machines have to work every day in the most extreme environment on the planet. They're being hammered by 100-mile-an-hour winds at temperatures below -50. This is engineering at the limit. But nothing lasts forever. Some of the A380s based here have now been operating for around 6 years. After 13 million air miles, they're being called in for a major aircraft MOT. The entire cockpit's just completely stripped away. See, this isn't just an oil change and a quick once-over. This is how deep they go in terms of stripping it back. God, look at that. All the seats are completely stripped out. And if you look, you can actually see all the floorboards have been removed from the upper deck. There's great gaps. And you can see the whole structure, all the wiring, all the mechanics, all the hydraulics. This is the strip down. A380s are made up of around 4 million individual components. And over an 8-week period, engineers will carefully remove 1,600 key parts. Then they'll pore over every inch of the empty shell. Inside each of these huge hollow wings are 49 horizontal ribs that maintain the shape and structural integrity of it. And each one of those ribs is supported by lots and lots of brackets. And if I just grab this light and climb inside, you might be able to see them. In fact, there's one that's been removed and is being supported. So that one's, there was obviously something wrong with it. It's being replaced. But they look at these brackets to make sure that there's no cracks in them at all or any flaws in them. The idea is to find a micro crack before it can spread and become a serious problem. Left unattended, even the tiniest flaw could eventually bring down a giant plane. Sometimes you might get cracks that are too small to actually see with the naked eye, so they've got this little device here. It's an electronic flaw detector, and this is one of the brackets here, which I'm just going to have a little look at. If I just put this wand, connect it to the metal, there we go. You can hear that beep, and there's a big spike on the screen. Right there is a tiny, tiny crack. And it's this incredible attention to detail that is so important in terms of keeping these enormous things in the air and everybody safe.
The edge of the Derbyshire countryside might not seem like the most obvious place for a high-tech hub, but it is, because these guys make over half of the new big passenger jet engines in the world. And the team in this building can tell you exactly what's happening with every single one of those engines right now, wherever they are on Earth. The engine is the beating heart of the aeroplane, the component we hope will never, ever go wrong. If a jet engine fails just once during its very long lifetime, the results are potentially catastrophic. So from this control room, Rolls-Royce keep a very beady eye on the health and well-being of their creations. What's going on here then, Matt?
So, in front of us here we can see the entire civil large engine fleet as it's currently flying. So we've got literally hundreds and hundreds of aircraft quietly making their way to their destination.
And this is where each one of them is in the world right now?
That's right, right now. This is their actual position as close as we can represent it. So each one of these aircraft is transmitting data that's being analysed all of the time, looking for those symptoms that might be indicative of a potential problem that we can do something about.
Around the world, the company has 4,500 large passenger jet engines in operation. Every one of them is in wireless communication with the Derby control room. Tiny sensors inside each engine monitor everything from operating temperatures to fuel pressure. Anything out of the ordinary gets flagged. The team are looking for warning signs of any potential technical issues. Are all of these ones behaving themselves at the moment then?
Yeah, right now we've got a well-behaved fleet in front of us, as you can see, which is how we like it to be.
Well, you guys can take the rest of the day off then, there's no problems going on.
Well, it would be nice if that would be the case, but things do go wrong from time to time, and that's what the team here is about.
With one of their jet engines taking off or landing somewhere in the world every 16 seconds, the team have to be ready for an alert at any moment. And despite all the high-tech monitoring, this time the cause is something rather low-tech. What's going on with that one there then?
Unfortunately, with this one of the baggage carts actually drove into the side of one of our engines. It does happen. So 200 or 300 people that were hoping to board a flight, they're pretty disappointed right now that they can't do that because of the damage that happened to that particular engine.
I love the idea that all of the precision that's going on here, everybody being so careful to ensure there's no problems with aviation at all, somebody goes and drives a baggage cart into the back of an engine.
Unfortunately, they did a pretty good job with the...
Smashing it up.
Yeah, so there's a couple of components that we're going to have to replace.
We all know the drill. Arrive at the desk, tag your bag, print your boarding pass, and head through security. Finally, you make it through. Get the obligatory supersized chocolate bar in duty-free, and then time to find the gate. Board the plane, and get ready for takeoff. That's all there is to it. It's all very familiar. But behind the scenes, there's a hidden world of complexity. Take your suitcase. Once you've checked in, your baggage sets out on its own long and secret journey before eventually joining you on board. Here in Dubai, they handle enormous volumes of luggage. In just 3 hours during the morning rush, they process around 50,000 bags. Stacked like this, they'd reach as high as Dubai's Burj Khalifa, the tallest building in the world. Annually, the airport handles a staggering 57 million items. That's equivalent to 1,100 Burj Khalifas. And it's all got to be whisked through the airport. Every bag must get to the right plane at exactly the right time. To make sure that happens, each individual bag needs one of these. The humble bag tag. So on your baggage tag, which we've all seen obviously, you've got things like your name, and then here we've got the DXB, which is a 3-digit code for the airport that you're heading to. But the really important thing is this mysterious 10-digit number along the bottom. This is like your bag's passport number, if you like. So the digits identify the airline, your particular bag's ID number, and then there's a special message digit which identifies the priority of the bag or any other information they need to know, high priority, low priority, that kind of thing. This code is part of the universal language of aviation, an international system that knows no borders. And it determines exactly what will happen to your suitcase after check-in. 25 meters beneath the airport lies a bizarre subterranean world. A sprawling 85-mile high-speed railway network. Costing around £500 million to build, this is the world's biggest luggage system. This place is absolutely enormous. Everywhere you go, there are just miles and miles of these conveyor belts with these trays that carry the suitcases moving along. It's really weird. It's like some kind of post-apocalyptic fairground ride. But the strange thing is you don't see any human beings. It's completely automated. It's like the robots have taken over. After check-in, your bag is spat onto a yellow tray. Each tray has been chipped with a unique ID, and a computer tracks which bag has landed in which tray. So each tray is specific for each bag?
It is, yeah.
Okay,
so instead of tracking that bag, we track the tray.
You track a tray instead, I see.
And that tray has an ID, which allows us to track it 100%.
The human being tasked with keeping an eye over this vast system is baggage manager Graham Pollock.
What we have around various points in the baggage system are what you see here is some read stations.
This thing here?
This thing here. This sensor will pick up the information from the tray. So the tray knows where it's going. It will tell this part of the baggage system, and here I am, please send me to this location. And then the baggage system will then divert it to the necessary output point.
The computerized brain of the luggage system plots every inch of your bag's journey to the aircraft. If your flight's leaving within an hour, the computer sends your baggage straight to the loading area. But for those of us with better timekeeping, our bags end up here, the early baggage storage system. If you've checked in a little bit too early, what happens is the bags will wait here, and then as soon as it's time for them to make the journey to the aircraft, a little red robot shuttle will whiz along here, pick up the tray and put it on the conveyor belt system, and then away it goes. Look, there goes a robot. The sheer volume of baggage moving through here is breathtaking. It simply can't be allowed to fail, so it's monitored constantly from the control room. There are more people working here than on the entire length of the conveyor system.
Copy the 886 and 374, you need to clear it fast, please. If it's taking time, let me know, please.
Can you just explain a little bit about how this works? Because it looks like a full-on something you might find in a railway network. It looks incredibly complicated.
Basically, you can see that right now, red, yellow and green. Green shows the system is normal, basically, the green color. So red shows a fault.
And there's also yellow as well.
Yeah,
so what is yellow?
Yellow is basically a queuing where the bags waits.
So it's basically like a traffic light. Green, good.
Yes,
yellow,
yes, yes,
might have a
yes.
problem. Red is like, ah!
Yeah.
This is the village of Gimont in southwest France. Nothing much happens here most of the time. But once every 2 weeks, in the dead of night, all that changes. Here it comes. Just coming through the mist. Such a weird sight seeing this enormous thing emerging out of the mist. This huge section of wing coming past and dwarfing the little French houses next to it. It's absolutely insane. These are the gargantuan building blocks of just one A380. Seeing them drive these massive sections of plane through this tiny medieval French village does really beg the question, why would you go to this much effort? Why would you drive these things down such a narrow country lane? The answer lies with its multi-billion-pound price tag. The A380 cost over £16 billion to design and build, so no one country could carry that risk. Instead, 4 nations invested: France, Germany, Britain and Spain. In return for their money, they each got the right to manufacture part of the enormous plane. This nocturnal procession is the result. The wings travel over 900 miles from North Wales. The fuselage made in Hamburg covers a similar distance. And the giant tail section over 1,200 miles from southern Spain. This is effectively a kit of parts that all come together here in France. And this convoy is the last leg of an epic European relay.
74 joins Sierra Juliet, hold short.
So right now we're doing the runway inspection. We're looking at any type of debris, metal, any types of bolts, screws, even plastic.
John Ryan is responsible for foreign object debris collection. I'm helping him scour every inch of Atlanta's tarmac. This runway safety inspection involves looking for any pieces of debris that might have fallen onto the ground from a plane or airport vehicle. Sounds straightforward enough, but there's just a 45-second window between landings to check an entire runway. And we're being chased by a 65-ton passenger plane.
We
were taking that runway, I think, at some speed, and only just got off in time for another plane to come into land. And this is the quiet period.
This is the quiet period, yeah.
John's looking out for even the tiniest objects that might have been left behind.
A screw.
Oh, really?
Gee, it's a nut.
Nut.
So that's probably off a bag cart.
Oh, okay. It's quite
Something,
warped, isn't it?
Yeah.
Is that dangerous?
Yeah, that's definitely a dangerous item.
Yeah. So you're driving along at 30 miles an hour?
Correct.
And that's it, that's enough to spot things like tiny bits of metal?
Correct, yeah.
You've got skills.
Yeah.
But a little bit of metal on the runway, how much of a impact could that have?
It could have a catastrophic effect.
Even fragments as small as this have the potential to wreak havoc. They could puncture a tyre or be flicked up and turned into a projectile, damaging an aircraft's fuselage. Sucked into an engine, a fragment could hit fan blades spinning at 10,000 revolutions a minute, causing serious damage. As a passenger, when you're coming into land, it just doesn't occur to you that there's a team of people like you looking out for things as small as this.
Correct.
That could have that dramatic an impact
I
as
know.
to have a catastrophic failure for the plane.
Yep, it's not just that airplane or a piece of metal. It's hundreds of lives that are at stake. So we are at the highest level of perception for any type of debris out there.
It's the job of the controllers here to keep track of the vast number of planes and make sure they never collide by fine-tuning their routes. Sean Sanders has ultimate responsibility for making sure this vital system works without a hitch.
Facility in a complex.
So Sean, tell me what we're looking at here.
So what you're looking at right now is every single aircraft that we're tracking via radar over the United States, and up here is Canada.
So these are all of the planes across America right now?
Right now, as we speak. What you're looking at is over 5,500 planes right now.
Wow. This looks like a swarm of bees. How do you even go about organising this chaos?
Looking at it like this, it looks like a lot, and it is a lot, but it's extremely organized. We have invisible highways in the skies, and these planes fly those highways to get from point A to point B. And each segment along the way, they make a left turn or a right turn or go straight until they get to their destination.
But is it almost as though you're looking at all of the cars in a city moving around, but you just can't see the roads?
Correct.
Ordinarily, it's busy enough, but over Thanksgiving, the controllers handle up to 9,000 flights in a day. That's on average 1 every 10 seconds. Preventing aviation gridlock takes total focus and concentration.
Next Wednesday is the busiest travel day of the year, the day before Thanksgiving here in the United States.
Are you really on edge on that day?
No.
Do you have anxiety dreams about this man?
Never. This is just what we do. We don't think about the number of people on the planes or how many planes. We know we have hundreds of thousands of people's lives in our hand, but that's not what's running through your mind when you're controlling these planes.
Okay, now I've got to try and remember how to fly a 737. Okay, Boeing. Okay, I've got that, flaps, gear. Okay, I'm ready. How hard can it be?
Here we go. If you're ready, V1, rotate. That's absolutely perfect there. Good.
It's funny, it's like anything when you do it for the first time, like driving a car, it's very, you know, it feels very complicated.
Speed is good at the moment.
Yeah.
All right.
Put my nose.
Now, as you put the nose down, remember that's going to have an effect on your speed, so you may need to adjust the thrust slightly.
Mercifully, I'm not responsible for bringing hundreds of innocent passengers safely down to the ground. This is a flight simulator. Oh my God, it's so realistic. It's so realistic. Captain Nick Coates is a top training pilot, and today he's bravely offered to let me try a landing.
So you need to ease it across to the left. Left a bit, left a bit.
Oh, sorry, left a bit.
The other left.
The other left.
Yeah. Just look inside occasionally. Check your speed, which is not too bad, and your rate of descent as well. We're looking for about 750 feet a minute on final. So you just need to ease that nose down a bit more. This is where it's possible that you'll start to shy away from the landing, and maybe you'll reduce your rate of descent and just pull the nose up a bit. So try and keep the aircraft coming down. Yeah. That's good.
Landing is one of the most testing phases of any flight. In here, Nick can make it even trickier by changing weather conditions. For my touchdown attempt, he's kindly thrown in some crosswinds.
That's it, you're correcting nicely. Keep the aircraft coming down. Don't increase the rate of descent too much. All right, a little bit off to the side of the runway. Okay, I have control.
Okay. Shit.
I have control.
Shit, sorry.
Yep, positive rate, gear up, thank you.
That is awful, I'm really sorry. Why did I hit it down so hard? Because I felt absolutely bang on, and then just that very last minute, the chunk.
Yeah, a bit of a gust right at the last minute can cause that kind of a harder landing. So the concentration then required in those kind of conditions is quite a lot harder.
Sitting here, you soon realise why it takes years to train.